back for this lesson. We are still on the equations of continuity and the fluid flow. And in this lesson, we want to focus on examples. We want to do some calculations based on the formulas that we have just derived from the previous lessons. So from this lesson, we want to see, we want to define the solution. So we want to calculate the flow rate. Here we want to look at the speed. But before we look at that, we want to familiarize ourselves with the formula. So as part of the solution, we want to state the formula. Earlier on, we were saying flow rate is also known as the volume flux. And the equation was equals to the area of the cross-section, multiplied by velocity. So in short, flow rate is given by the area multiplied by the velocity. So let's go to the question. Example 1, we are told a lawn sprinkler has 40 holes. So that lawn sprinkler has 40 holes of a cross-sectional. So each hole has got cross-sectional area of 2.0 times 10 power negative 2 centimeters square. It is connected to a hose pipe of cross-sectional area 1.6. And then we are told if the speed of the water in the hose pipe is 1.2 meters per second, then calculate the flow rate in the hose pipe. So the question is, we want to calculate the flow rate in the hose pipe. So now we say hose pipe, we want to determine the flow rate. So what have we been given? We are told it is connected to a pipe of cross-sectional area. So this one has got the area of the hose pipe, area of hose pipe. We are given to be 1.6, and you remember to give it in the correct unit. It is in centimeter. We are supposed to change it to meters, meaning that we are going to multiply by 10 power negative 4 meters square. Then we are also being told that if the speed of water in the hose pipe is this, in the hose pipe again, the speed is equals to 1.2 meters per second. So using our formula, the flow rate, which is equals to the area multiplied by the speed of the velocity. Our area is 1.6 times 10 power negative 4. The speed, which we are given there, multiplied 2.31. By using your calculator, you can get something like 1.92 times 10 power negative 4 meters per second. So this was meters square. This one is meters per second. So it's going to be meters. It's going to be the product of this m squared and then that one. So we're going to get m cubed. S is supposed to get that. So the flow rate of the hose pipe, this is of the hose pipe, is this. Now you go to question B. Then we also ask calculate the speed at which water emerges from the hole. So calculate the speed at which the water emerges from the hole. So we go back to this. So we've got the sprinkler, the low sprinkler, we have the sprinkler, and we have the hose pipe. Now we know we have the hose pipe. We know the flow rate for this one to be 1.92 times 10 power negative 4. This one, we know the area, so we can calculate that. Based on our earlier equation, we were saying it was constant. A phi was equals to constant. So what does it mean? It means if we to take A, we take S as a sprinkler, S multiplied by the speed, S, which is the sprinkler, is equals to the area of the hose pipe. We take this first letter H to be the hose pipe, H multiplied by phi, H. This should be constant. Should be equal. If that is the case, then we can equate the two. So from the hose pipe, the area is this, the hole, but we have got 40 holes, meaning that we're going to say 40 multiplied by 2 times 10 power negative 2 multiplied by phi, which we don't know, must be equal to 1.92 times 10 power negative 4. So you can clean this. So from here you will need to change this to the correct unit. So we are going to say 40 times 10 times 2 times 10 power negative 2 times 10 power negative 4 times phi should be equal to 1.92 times 10 power negative 4. So the product of this should give us 80. So 80, 80, cancel with that, we're going to get, use a calculator, 40 multiplied by 2 times 10 power negative 2 times 10 power negative 4 times phi, which we are looking for, should give us 8 times 10 power negative 5 times phi should be equal to 1.92 times 10 power negative 4. So by dividing both sides by this, we divide both sides by 8 times 10 power negative that, then we are going to get 1.92 times 10 power negative 4 all over 8 times 10 power negative 5. Now, if you use your calculator, you are supposed to get something like 2.4 meters per second. That is the solution. That is an example. Some of the questions we might come across in questions of continuity and the fluid flow, but most of the time you have to remember that flow rate is equal to the fluid flux, and this is also going to be equal to area multiplied by the velocity. And they are giving us in speed, so speed and velocity are just the same. It's only that the speed is a scalar, velocity is a vector quantity. They have the same unit. Thank you.